A capacitor is a basic electronic component. A capacitor can store electrical energy in the form of a charge. This fundamental action accounts for many of the properties of capacitors used in electronic circuits. The various kinds of electronic equipment that we see here use capacitors. In modern electronic equipment, which uses integrated circuits, capacitors are incorporated in the chips. In this program, we will study the basic properties and applications of capacitors in electronic circuits. Here we see various types of capacitors. These are used for different purposes in electronic circuits. The capacitors are checked in the laboratory according to the specifications for which they are manufactured before actual use. A capacitor consists of two metal plates separated by an insulator called the dielectric. When a capacitor is connected to a battery, the positive of the battery attracts electrons from plate Y, and the negative repels electrons to plate X. A positive charge builds up on Y, and a negative charge builds up on X. Charging stops when the potential difference between Y and X equals the EMF of the battery. When we open the switch, the charge remains. This experiment demonstrates that a capacitor can be used for storing a charge. The amount of charge stored depends on three factors. First, the potential difference, or PD, between the plates. The larger the PD, the greater the amount of charge stored. Second, the total area of the plates. The bigger the area, the larger will be the charge stored. Thirdly, the closeness of the plates. The closer the plates, the more is the capacity to store the charge. When you connect a battery across a capacitor, the charging process starts. The capacitor charges slowly till it is the same as the battery potential. The rising curve shows that the capacitor is slowly charging till it attains the same potential as the battery. If the battery is removed, the charge may take a long time to leak away. The falling curve shows the decay of the charge. We may compare the charge with water in a tank. The height of the water is like the potential difference. If we open a tap, a current of water runs out. The higher the level of water, the stronger the current. We see here two tanks, one wide and the other narrow, filled with water to the same height. This experiment demonstrates the analogy between the flow of water from a tank to the flow of charge from a capacitor. The tanks are fitted with taps which offer resistance to the flow of water. When we open the tanks, the same current of water flows from both the tanks. Now we open the taps. As the water level falls by the same height, we find that tank A loses more water than tank B. The width of the tank can be compared with the capacitance of a capacitor. The greater the capacitance, the greater the amount of charge it can store. The capacitance of a capacitor measures its charge storing ability. If a current of 1 ampere flows for 1 second, the amount of charge it carries is 1 coulomb. If the potential difference across a capacitor rises by 1 volt while it gains 1 coulomb of charge, its capacitance is said to be 1 farad. This is the measuring unit of capacitance. Here we see different varieties of capacitors. The basic properties of a capacitor are its storing capacity, its charging and discharging ability. For different purposes, different types of capacitors are used. They vary in size, working voltage and capacitance. Here is a diagrammatic representation of a polarized capacitor along with its symbol. This is also called an electrolytic capacitor. Electrolytic capacitors are made to hold large amounts of charge. They have large areas rolled around each other to make the capacitor compact. An electrolytic capacitor has a positive and a negative terminal. These terminals must be connected at the appropriate ends so that there is a DC through them in the correct direction. The capacitance of a variable capacitor can be varied over a wide range. This capacitance depends on the size, the area, and the distance between the plates. The dielectric in this type of capacitor is air. The plates are rotated by a movable knob. At a particular set position, the capacitance can be fixed for the required value. This chart shows the properties of different kinds of non-polarized capacitors, like polyester, mica, and ceramic. They are available in the values indicated in the chart. Non-polarized capacitors are available in different shapes and values. The dielectrics commonly used are mica, polyester, and ceramic. They are used through the frequency range from audio to very high frequency. Non-polarized types can be connected either way round. There are no positive or negative markings on this type of capacitor. This chart depicts the properties of polarized capacitors. They are used for low frequency and low voltage applications. Their values must be checked for a specific use. Polarized capacitors, like non-polarized capacitors, are fixed-type capacitors. The value of the capacitor is non-adjustable. They are usually constructed from plate or metal foil The values and working voltages are generally marked on the body of the capacitor. These capacitors can be identified for precise use. The capacitance values of the capacitors are also marked with the help of color codes, as for resistors. The first band indicates the first digit. The second band indicates the second digit. The third band indicates the number of zeros. And the last band indicates the tolerance values. The values are printed on the body of the capacitor. The positive sign signifies that it is an electrolytic capacitor whose working voltage is 12 volts and capacitance is 2000 microfarads. Variable capacitors are used for tuning in electronic circuits and radio receivers. By rotating the knob of the variable capacitor, the exact position at which the circuit is tuned can be located. Trimmer or preset capacitors are also used as variable capacitors for fine-tuning. Capacitors do not allow DC current to flow through it. If a battery is connected in series with a capacitor and a lamp, the lamp will not glow. The capacitor will allow AC current to flow through it. If an AC source is connected in series with a capacitor and a lamp, the lamp will glow. This property of allowing AC to pass is utilized in electronic equipment. It is very important to know how the capacitors are connected in an electronic circuit. When two or more capacitors have the same charge, the capacitors can also be connected in parallel. The potential difference across each capacitor is the same. Capacitors can also be connected in series or parallel combinations. In an amplifier circuit, the capacitors are connected in series or parallel combination. Capacitors are used to separate AC from DC. That is, if the output from one circuit X contains AC plus DC, but we want AC to pass to circuit Y, a capacitor can be used to pass AC only. This property of AC coupling is used in electronic equipment. If AC is required to be stopped from going through a particular electronic circuit, a capacitor in parallel bypasses AC through the capacitor as it gets an easy path. A battery charging device contains a step-down transformer, a DC rectifier, and a capacitor which supplies a steady DC voltage required for charging a battery. In a battery eliminator, a transformer steps down the mains voltage to a lower voltage. A rectifier converts AC voltage to half-wave DC voltage. The DC voltage we get from such an arrangement is called a half-wave rectifier. The DC output in the form of half-wave is very inadequate for use in any equipment which requires a steady DC voltage. In a full-wave rectifier circuit, the DC output that we get from a rectifier bridge is in the form of a pulsed half-wave. This kind of circuit arrangement is known as a full-wave rectifier. The AC input is a sine wave. The secondary side of the transformer is connected to a full-wave bridge rectifier. The bridge rectifier rectifies the positive and negative half of the AC input into DC output. But the DC output that we get is not very smooth. To get a smooth DC output, a capacitor is connected at the output terminals. When a capacitor is connected at the output of the rectifier, the output is very smooth and steady. And the wave shape of the output voltage is almost like a straight line and is not in the form of pulsed half waves. In a DC power supply unit, we get a very steady DC output voltage. An electronic flash gun unit supplies the light for taking a photograph. In a flash unit, the properties of charging and discharging a capacitor are made use of to create a flash. The capacitor placed inside the flash unit is charged to a high voltage, and as soon as the camera is triggered, the capacitor in the flash unit is discharged through a lamp in the flash unit. Through this program, we have learnt that a capacitor is a basic electronic component. It can store electrical energy in the form of a charge. The amount of charge stored in a capacitor depends upon the potential difference between the plates and the distance between the plates. The capacitor allows AC to pass through it, but blocks DC. A capacitor allows only alternating current to pass through it. This property of the capacitor is used to separate AC from DC. There are different types of capacitors, such as fixed, variable, polarized, and non-polarized. Capacitors are widely used in electronic and electric circuits. If a capacitor is charged, the voltage across it rises. When it is discharged through a resistor, the charge disappears, which is represented by a falling curve. Can you draw the graph if a capacitor is charged and discharged repeatedly?